company website www.alumnimit.ac.in. Industry, I think education is there or not. I don't know.
College or university
College
is
or
there.
university. Okay. Then manufacturer. Perfect. Texas Instruments. This one. Okay. Texas Instrument. TI. And then you can go for these options according to your choice. What is the reason for your interest in the product? I'm curious. Okay. Or I'm looking for tool to okay, no, I'm curious. Then what is the rough time frame? Greater than 12 months. What is the appropriate number of developers? 2 to 5 or 1. It is your choice. I agree, and download the software. Okay. Okay. Similarly, you have to download Codeblocks. Okay. This one. In here, you can go to downloads, go to binary release. Those who are having Windows can download from here the latest version 20.03, or those who have Mac or Linux, they can scroll down and download the softwares from SourceForge. Okay, prefer the SourceForge, it is good, open source. Okay, so in this way you can download and install the software. Okay, and then we will start working with the software part. In the last lecture, anyone having any other difficulty?
Okay, sir.
Hmm.
So in this Texas instrument part of IR,
Hmm.
if we choose any other option, is it going to make difficulties or something?
No, yeah, because we are going to use Texas Instruments board. In this course, we will be following Texas Instruments board. That's why I was opting for TI.
So at that time, I already downloaded it and I didn't know it. So
I don't think there will be an issue. We can check that later. Don't worry. Okay, we can add if there is, you have downloaded it for different version, we can add those tools otherwise. Okay, don't worry. I'm actually exploring some other options also, in which you can what to say, this not this one, in which you can try the online version of this software. Okay, but unfortunately today I tried a lot but failed. Soon I will find some solutions for the Mac and Linux guys. Otherwise, those who are having Mac or Linux can try some virtual machine kind of thing, in which you
सर
can run. Yeah,
IR डाउनलोड में ईमेल एड्रेस पर्सनल यूज करना है या कॉलेज का?
college. Prefer the college ID. Don't
ओके
worry.
ओके
Okay. Okay. So in the last lecture, we were talking about the comparison between Arduino IDE and C++. Okay, and I showed you in the end that Arduino IDE takes somewhere around 1 kilobyte of memory space just to blink an LED. And then I used a similar code from C++, and it took only 160 KB. So we reduced the size of the code by somewhere around 80 to 90%. Apart from that, we also reduced the size of dynamic RAM, or the variables that were used in the dynamic RAM also. So it was both in case of the size and the speed. It was a win-win situation using C code. Okay, so it was fast enough compared to the Arduino IDE. Today, just I'm going to talk briefly about EMI and EMC solution. And in the last, I was trying to develop this slide, but I was unable to finish it. Anyway, so let us just briefly talk about this part and it is important and why the world is moving towards EMI, EMC solutions. Okay, and it is getting more and more value in these days. You all know that almost all the devices, okay, be it a drone or be it an aeroplane, car, mobile phone, wristwatch, almost every device or every thing that you see around you contains some kind of communication equipment in it. Mostly we are talking about wireless communication equipments. Of course, this same concept of EMI, EMC can be applied for wired and wireless solutions both. Okay, it can be checked in wired and wireless solutions. So these are related to all the equipments, okay, which are having some wires or wireless solutions attached to it. So what happens when you are having a Bluetooth, okay, or GPS or Wi-Fi or any other device? So all these are different standards of communication, right? Standards. So these standards require some important features, like how many of you know the frequency in which Bluetooth works? Frequency. And then how much power is allowed to be transmitted in the Bluetooth? So one is the frequency band. Okay. Second is the power, radiation power which is allowed. Okay. Power radiated. Okay. Third, the data rate. So these are the some of the very basic things that an engineer should know before going to choose any particular solution, be it GSM, GPS, Bluetooth, or VFH, very high frequency solutions, RF modules, and all those. Okay, so before going to select any technology, we should know these things: the frequency band which is allowed, the power radiated which is allowed, the data rate which we can achieve. Okay, so because these signals are going to radiate around that particular device, be it your mobile phone, because mobile phone has got almost all kind of solutions. Wi-Fi, right? Mobile phone has Wi-Fi. It has got Bluetooth, BLE, okay, BLE, okay, BLE, and then it has got GSM, and all kind of mobile standards are always almost there in the mobile. So there is radiation which is generated due to all these frequency bands and standards. These radiations may or may not interfere with nearby devices. For example, whenever we enter into an aeroplane, they say that please turn off your mobile phones or any wireless equipment before before the takeoff, and they allow you to switch on your mobile phone or any other devices only after you land at the airport. Why? Because your mobile phone or any other wireless equipment may interfere with the signals that are arriving or that are transmitted from the aeroplane, and which may cause disturbances or may sometimes even block the communication between the aeroplane and the what to say, the tower where they communicate. So to avoid these things, okay, there are standards which allow only particular frequency bands, power, data rate for different standards, and we should not go beyond that. Otherwise, what may happen, even for research purpose, if you are radiating signals which are not allowed for the common people, then you may be easily arrested by the government of India or any other government. Okay, so for that you must know all these details. So EMI and EMC are the testing which are conducted almost all the devices, be it wired or wireless devices, to check whether they can radiate or they will radiate some signals which may interfere with nearby devices, or they can even resist those signals which are coming from outward, okay, outside world. So for that, first testing is EMI testing, which is called electromagnetic interference testing, and EMC stands for electromagnetic compatibility testing. Okay, these two tests are conducted almost in all devices nowadays, be it wired or wireless. Okay, what are the things that they do during these tests? They check whether these systems are emitting unwanted signals, or they are emitting more power than that is allowed for those kind of devices? If so, then such devices are not allowed in the market. Similarly, immunity testing, that means how strongly your device can stand for any signal which is coming from outside world. For example, you are working with, you are a doctor, okay, and in the hospital you have a cardiograph or something which in which is connected to a patient, okay, which is showing the heart rate of the patient. Now suppose this doctor is using a mobile phone, right, or any other wireless device which is radiating signals, right? So this device, cardiogram or any other device, if it is getting interfered with the mobile's radiation, then you may find some wrong signals which are generated in the cardiogram, and that will result in wrong diagnosis also. So therefore, when you test these kind of devices, medical equipments or any other device, you check how immune these systems are from the outside world's signal. Okay, so both how much signal is allowed or how much power is allowed to be radiated, at the same time how much external world's power can be be resisted by your device. Okay, in the past when we used to watch televisions, okay, in the roof we used to have some antennas like this. Have you seen this kind of antennas in the roof? Even you can see this kind of antennas nowadays in some of in the rooftops or any other antenna. Okay,
Okay.
so
Yes.
in these antennas, when we were child, okay, I'm talking about that time period when there was a scooter, okay, so if you switch, if you kick the scooter, okay, I'm talking about the scooter, okay, if you kick the scooter in that, in those old days, the scooters, when it was getting started, okay, during that time all the signals that we see in the television used to get disturbed. Why? Because scooter used to generate, you know, spark plugs are there, spark plugs are there, right? Spark plugs generate some sort of sparks, and sparks are nothing but a band of frequencies which are generated with a huge power. So spark plugs generated from the scooter used to come and interfere with the antenna, and the antenna which was receiving the signal from Doordarshan or any other channel used to get disturbed, and it was visible in the television also. Even now you can see such kind of interference. For example, whenever you are using a land phone, okay, whenever you are talking with the land phone, and if your mobile is very close to your land phone, you will find some noise generated in the land phone due to the mobile. This kind of signals, that means the land phone is not immune to the signals which are generated from the mobile. So how much immunity that device has got? Okay, so that all are important when you are doing EMI EMC testing. So your product will be more robust if it can withstand external electromagnetic interferences. For example, magnetic fields which are radiated from electrical wires. We all know that by Coulomb's law, or you can take the law of current. Whenever there is a current flowing in any conductor, it generates a magnetic field around it. We all know these concepts, but how many of us know that these currents or these magnetic fields or electromagnetic fields can interfere with nearby equipments also? Okay, so every conductor which is carrying some current will generate electromagnetic field, and it can interfere with nearby devices. Even it may interfere with nearby lines also. So in during lightning, for example, when there is a lightning, you will find disturbances in your television, or suddenly the voltage rises or the current rises. So those are again electromagnetic kind of interference which is generated. Okay, so EMI EMC testing is one of the hottest topics. If you are interested, you can go and explore this. And there is a huge demand for engineers who can work in this domain also. And of course, whenever you are designing an embedded system, mostly we will be using embedded system to communicate with nearby devices, and any external electromagnetic signal can change the behavior of your system. Okay, and that should be avoided, and for that you should know how to go for EMI and EMC testing. If you come back, if you have the opportunity to visit the Alumni IIT or the college, okay, do recall, remind me, I can show you this testing, how to do this kind of testings. Okay, otherwise just let me show you one very simple project which you can develop it in your home also. Okay, and it is very, it is a kind of what we can say, the EMI EMC testing kind of thing we can say like that, how much signals are generated from the external world. um, Wireless power tester, I think, sorry, not tester. Okay, let me show you something like this. I'm just showing these things so that you should know, feel attracted toward these kind of things. Try to make the things and it will be helpful for you. Check this. Okay, let us move ahead. Okay, so please try to explore more such products around you. Okay, because there are so many fascinating experiments that you can do, you can make, and without even breaking your walls, you can test the power, or the, if there is any wire which is broken inside the wall, you can even test that part also without even breaking the walls, where the wire is actually broken, without breaking the walls. Okay, you can test with this kind of instruments, and it is not that complicated. I believe most of you can design something using transistors like this. It is not a very complicated circuit, is it? I don't think so. Even you can use two transistors. It is not mandatory that you always go for three transistors. Okay, so it is a very simple circuit, and you can design something like this. This is also an embedded system, you can say, though there is no programming involved in that. Okay, okay, so this is all about EMI EMC testing. And similar kind of product is used by some of the ghostbusters also. You might have seen some people who are carrying some instruments which they say ghosts are nearby, so they are generating electromagnetic radiations. So I don't know whether the ghost can generate electromagnetic radiation or not, but they carry similar devices. Okay, anyway, now let us go to our course. Now we are going to talk about the ARM Cortex microcontroller. And before starting to write any code for any device, we should know what are there in that device. Okay, and then of course we will go to the C and then start writing program in the software also. Okay, so from here we are going to talk about the ARM Cortex M4 microcontroller, because we will be using M4. Okay, so ARM Cortex M4 microcontroller. Okay, so first of all, how many of you know that know about this particular company, ARM? How many of you know ARM? Have you heard of ARM?
Yes, sir.
Okay, this
Yes, sir.
company, yeah, this company, remember this company do not produce any microcontroller or microprocessor. Okay, they do not produce produce microcontroller. It is just like Uber. Okay, Uber is providing you taxi services, but Uber do not produce or make any taxi. They do not have a single taxi with them. They are just service provider kind of thing. Similarly, Zomato, it is just providing you the food service. They don't have any hotels with them. Similarly, there are many other what to say firms which are providing solutions, but they are not producing it. Okay, so the ARM company produces the IP, intellectual property for the microcontrollers, and they sell these designs to almost all companies, be it Apple. Apple take microcontrollers design from ARM, Samsung, okay, you name it. Even nowadays, Intel is taking IP solutions from ARM. So almost all the companies are taking ARM's microcontroller. So I believe the market share of ARM is more than 90%. So 90% of the ICs nowadays, or microcontrollers or programmable ICs, are produced using ARM. So knowing this architecture, only this architecture will help you to design almost all kind of embedded system, be it Texas Instruments microcontroller, be it STM microcontroller, or any other company. Okay, so let us briefly see what are the things available in the ARM. So ARM stands for Advanced Risk Machine, okay, architecture. So advanced risk machine. Risk stands for reduced instruction set computer. So, so, so let us briefly see how the ARM actually, what are the different microcontrollers or processors developed by the ARM. So here we have in the x-axis capacity. So that means when you move towards the right, you have higher capacity. When you move towards upward, you will have higher functional performance and all. Performance is increasing. Okay. So first of all, the ARM started with classical processors in which you can have ARM 7, okay, ARM 9, and ARM 11. These are classical microcontrollers. So these were the time when the ARM was evolution taking place in the ARM, and then these were the primary solutions by the ARM. Of course, ARM 11 has more functionalities and features than ARM 7. Then later, ARM started producing embedded processors. Okay, those processors which are for embedded technology or embedded engineering. Okay, so microcontroller kind of thing. So started with ARM Cortex M0, M1, M3, M4, and so on. So we are going to study about this particular microcontroller, which I believe is almost more than sufficient for all kind of embedded system designs. Okay, so we are studying some of the latest things which are there in the current market also. So ARM Cortex M4. Okay, we are going to study about that. Apart from that, ARM also generates application oriented microcontrollers or processors which are focused for a particular application only. So can you tell me any of these microcontroller where these processors are used? A series. Have you heard of A series in any other application?
Mobile processors.
You know, Apple's, yeah,
Mobile
Apple
processors.
uses all these versions. Yeah, mobile processors because they are oriented for a particular application. Particular application, okay, for even maybe used for particular video processing or some other processing. So application oriented tasks. So Apple, Samsung mobile phones, all the mobile phones mostly use processors from A family, A application family. So you have three families: classical Cortex processors for embedded systems and Cortex processors for application oriented jobs. Okay, so I don't know the current version, but I think A15 is the latest version. Anyway,
Yes, sir.
so these are the evolution or the lifespan of ARM's microcontrollers. And remember, we are somewhere here. We are going to study about this microcontroller. Not a bad solution for embedded systems, because we are talking about embedded systems. Okay. Now, so there are three versions: application oriented task, real time task, and all. Okay, real time, that means the solution should be generated at that very moment. Real time applications like airbag solutions, or the solutions for the drones, or for missile technologies, or for medical equipments, where time is more important than the task. Time is more crucial, where you should not miss any crucial millisecond. Also, you have to take the decision within that particular time. You cannot wait for example, Windows is not a real time operating system, where sometimes copying may take some more time than the other time. That means it is dividing the task depending on the heaviness of the task. Whereas application real time operating systems, they value the time. It is not that you should always go for real time, so RTOS, okay, because this real time means real time operating systems are there. So you don't have to always go for RTOS, but there are huge demand for RTOS based solutions where time is more important than the task. Okay, task has to be done within that time. So okay, so classic processors and ARM Cortex processors, you can divide these two families simply. Okay, so what are the things that we can remember? So microcontrollers and deeply embedded systems are within these families. Okay, Cortex M0 to M10. Okay, M4, M4. Nowadays M8 are also there. M8 are coming. So we are here, somewhere here. Not bad from the Cortex family's perspective. Then there are real-time processors which give more priority to time-oriented applications. They are application-oriented series like M7, ARM7 and ARM9, R5, R7. Okay, so these are based on R, R, R. Okay, so real-time processors where the time is more important. So totally the architecture will be different. The approach to program these microcontrollers will be different, and the goal or the target or the solutions which you can generate using these microcontrollers are different. So before opting for a microcontroller, you should know for which purpose you are taking that microcontroller and what are the capabilities. Apart from that, there are microcontrollers which are generally used for very specific tasks for operating systems like mobile operating systems, Linux, or any other solutions. In that family, you can have ARM series 11 Cortex A. You can see A series. Okay, so these are the microcontrollers or the processors which are more oriented towards application oriented tasks. Okay, for particular operating system or particular device or something like that. Okay, so you can broadly segregate or separate these three families also. So keep note of these things. You are not going to explore all these microcontrollers in your life, but you should know that if you have to select a microcontroller or a microprocessor before the starting of the project, if you are responsible to choose a microcontroller or a microprocessor, then you must first segregate these microcontrollers according to the type of task that you are going to do. If it is an embedded system, always go for Cortex M families, embedded solutions. Or if you are going for real time applications, try to go for R based solutions. R, okay, here this R families. If you are going for application oriented task, or OS related tasks, go for A based microcontrollers. Of course, that will be the backbone of your company. Based on that, you will create the architecture for your solution, and that company will grow on that particular platform. Okay, so designing a device or designing a solution is not just for 1 month or 2 months. It should continue for generations, maybe for 5 years, 10 years. So you have to opt a microcontroller or microprocessor with that seriousness. Okay, otherwise you cannot keep on changing the microcontroller from year to year. This is very important. Okay, now ARM microcontroller follows a very basic principle that is called load store model. Okay, what does that mean, load store model? It is a very simple model. Okay, and ARM always use this particular model, that is load and store. What is this model basically? Load store model basically means the ALU. I believe almost all of you know what is ALU, right? Let me pick someone. Okay, let me go to someone. Shivang Sharma. Shivang Sharma. Shivang Sharma. Are you online?
Yes, sir.
Hello. हाँ तो can you tell me something about ALU? What ALU stands for? What is the purpose of ALU in any system?
Sir, ALU stands for Arithmetic Logical Unit.
Arithmetic
Logical
logical
unit.
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 What is the job of this particular device or this particular block?
Sir,
Basic mathematical
in,
रुको
functions.
रुको उसको बोलने दो ना, उसको बोलने दो, डोंट वरी, उसको बोलने दो. हाँ
sir, in microprocessors, ALU was used to change the address lines into data
नहीं
transfer
यार,
line.
देखो तुम नाम भी बोल रहे हो, तुम गलत बोल रहे हो. अरिथमेटिक लॉजिकल यूनिट. What is this unit going to do? Arithmetic stands for what?
Sir, calculations and
Like what?
like addition and subtractions,
And multiplication and division,
division.
modulus, like this, right?
Yes, sir.
Arithmetic instructions. Logical unit.
Sir,
What?
logical unit like AND operator and
OR
XOR
operator,
and
XOR and all.
yes,
So
sir.
that means all the mathematical or logical related task will be conducted within this particular block ALU. So remember this, okay? It is not about addressing or something. It is all about mathematical tasks which are to be done on the operands. This block will do that part, okay?
Okay, sir.
Okay, so remember in ARM load and store model, ALU never directly communicates with the memory. No, it do not communicate directly with the memory. Whereas if you recall, 8085 was able to directly communicate with the memory. That means it can directly go and do some mathematical operations with the data in the memory also. But here, no, ALU will not do that. So what the ALU will do in this particular thing? First of all, let us take an example of load operation. Load means the data will be coming towards the ALU. Load, right? Load means if you have MPU, microprocessor unit, or microcontroller unit, MCU, okay, and there is a memory. So load stands for this particular task. Data will come from memory towards MPU. So in the load operation, the load will take place only between the memory and the temporary registers. It will not directly come to the ALU. It is not allowed. Remember. Simple, okay? So load operation will take place only between temporary register and memory. You cannot directly take the data from the memory to ALU. It is not allowed in ARM architecture. It has its own advantages. It has all its own disadvantages also. But anyway, they follow this particular technique because they want to make it fast. Here, the speed is more important than the complexity of the system. So there is a big difference between Intel's microcontrollers or Intel's microprocessors and ARM-based microprocessors. ARM based microprocessors are mostly for reduced instruction set. That means smaller instruction set, faster processors. Whereas Intel, which is still following the old architecture, that means it is for complex systems where you have more operating systems related tasks to be managed. Okay, so there in that case, you can directly do the the ALU related task within the memory also. You can directly transfer that to memory, but here it is not allowed. Okay, the load will take the data from memory to temporary register, and then only the data which is in the temporary register can be used by the ALU. ALU will not use the data from temporary memory, main memory. Okay, remember this. When it comes to store means just opposite of load. That means the data will go from the microprocessor towards the memory. In that case, the ALU will first take the data, process it, store it in the temporary register, and then the temporary register's data will go to the memory. Some of you may ask, then how it is becoming fast, right? If there are two steps to move to the memory, how it becomes faster then? Any solution, any answer? Why it is fast? Why do you think this technique is faster than the technique to directly go to the memory?
So because
Anyone?
memory is much larger than the temporary register.
Okay, first thing, memories are larger. Apart from that, any other reason why it is slow?
So temporary register becomes kind of a buffer zone.
Okay, let me go back to the memories itself. What are the different memories available in any system? Memory. If I have a microprocessor or a microcontroller unit like this, what is the structure? For example, this microcontroller unit is there, MPU. Above that, which memory is the closest to MPU?
Cache.
Cache memory.
Cache. Okay. Then after that,
RAM.
RAM. Perfect. And then of course after that you have the external memory, be it HDD or something. Okay,
hard drive.
hard disk drive. Okay, and then of course apart from that, if you go further, then you can have secondary storage devices like USB drives or CD drive or something, which are the slowest. Still they are memories, right? So cache, this is the memory architecture for a computer, right? For a computer, or a PC, personal computer. But what about the microcontroller or a microprocessor itself, which is the closest memory to the ALU? Instead of MPU, we'll have ALU here, right? ALU. So which is the closest memory to ALU? Temporary registers.
Temporary registers.
Why you have to have confusion in this? Temporary registers are the closest memory which are there to the ALU. If you go speed wise, this is the slowest, right? Slowest, and this is the fastest, right? Fastest. So temporary registers are the fastest, and the secondary memories are the slowest. So temporary registers are the fastest, and the technology which is used, anyone having any doubt now? The technology which is used to design temporary register, please investigate this thing, temporary registers, okay, or cache. Okay, if you are talking about the computers, the technology which is used to design temporary register and the external memory or hard disk or USB drives, or you can say RAM and HDD. What are the technologies used? What is the maximum data rate they can support? Please go and explore it. That will tell you why the ARM opted for avoiding the memory rather than it preferred the temporary register itself to handle the data for ALU. Why? because the in the temporary register the data will be first stored. Might be possible you need it again, and in that case it will be much faster to access the temporary register than to access the external memory, because it will slow down the whole system in total. The average speed will decrease, right? Got it? Anyone having any difficulty to understand why load and store architecture is faster compared to the previous architecture that you studied in 8085, where you were dealing directly with the memory?
No, sir.
No, sir.
So please remember these things, because these are the things which are generally asked in the interviews also. Why ARM processor? ARM is using 3-stage data transfer, but still it is faster. Why? Because temporary registers are much faster than this memory. It is not about the size, it is about the speed. This is slower. Okay, this is slower than the temporary register. People may ask, then why don't you create the RAM itself? Why don't you go and create a RAM of 30, 100 GB, 100 GB RAM? Why? Why not possible? Or 1 TB RAM? If the RAM is fast, why don't you go for the RAM itself? Why do you keep hard disk? Throw the hard disk out. Let there be a 1 TB RAM. Why we don't go for that technology?
Cost.
Sir, cost and size.
Cost, because the technology matters. The cost, the things that they are using to create that kind of memory. The technology, when I am saying technology, for example, if you can remember silicon, germanium, okay, and many other combinations of these kind of alloys, maybe with silicon, with germanium, or any other device. Okay, diamond, even diamond is one of the solutions. Okay, silicon carbide, MND, silicon carbide, and their GAN, gallium arsenide kind of thing, gas, GAN, GAN, GAAS. So these are the this is what I am talking about, the technology. You know which one is the slowest in this? For example, okay, I don't know about this diamond right now. Silicon is really slow. You know this thing. Silicon is slower than germanium. In the very beginning of the computer era, most of the microcontrollers were designed, or microprocessors mainly, microprocessors were designed using germanium. It was much faster, very much faster than the silicon. Then what happened? Why they removed this germanium from the market? It was fast. This was fast. Then why silicon dominated the chip market?
It was cheaper, sir.
Cost.
Abundant.
No, no. It was not about the cost.
Abundancy.
No, any other reason? Look, whenever something is too fast, now it will generate too much
Heat.
heat. And whenever there is too much heat, you have to put more and more power for cooling systems. Okay, and that is the bottleneck. You cannot go beyond a particular speed, otherwise you will have to spend more energy to cool the system. And this is the bottleneck of one of the reasons why the speed of computers still are within the 2.4 or 3.2 gigahertz range. Let me tell you, when I was doing my engineering at that time, 2003, there were processors which were running at 3.4 gigahertz. And even now, in 2021, you will find most of the microcontrollers are at the same speed. They have not increased the clock rate, because if you check the board the computers that we were using, it was having a very small fan. Nowadays it has got a very big fan in the heat sink. More power is utilized in that. Nowadays there are many cooling techniques also used. Anyway, that's our secondary part. Whenever you want to explore, you can go in that part. So that's why, remember, ARM uses load store technique, or it follows load store model, because it is much faster than the
Excuse me, sir.
mhm.
Sir, then why people are still using Intel chips if ARM is better?
it is more, like I said, it can support more complex mathematics. Reduced instruction set, RISC, because ARMS, R stands for risk, remember this thing,
Yes, sir.
RISC, risk architecture. So risk architecture means reduced instruction set. So instruction set is small and it is much faster. Okay, but you cannot do complex things then in that case,
Okay, sir.
where you need more image processing, more data crunching kind of things. This will be, overall the speed will be reduced in that case. It is good for
But
mobile kind of applications and all, but still risk is when you
but sir,
Mhm.
we are using M1 chips now. They are ARM based.
ARM based, yes, in laptop.
Nowadays it is coming up. I told you Intel is also taking ARM based solutions now. The things are changing now, that there is a big, before we used to say that microcontroller, microprocessor, the difference is the memory. Nowadays there are microprocessors also which contains memory, so that this gap is diminishing, or it is changing with respect to time. Risk architecture, in the beginning, what I am telling you is about from the point of view of M4. Okay, I'm not talking about the point of view which is generating the latest microcontrollers like M8 or M10. Okay, there is a total difference in that architecture itself. But still, if you see, if you still want to go with the workstations, when you go for GPU kind of solutions, where you have more processing related tasks to be done. In our college, we have purchased one supercomputer, right? We have supercomputer in our college. How many of you know that?
Yes, sir.
Do you know which kind of processor is used there? Is it ARM or still with the Intel Xeon or model like that? Please go and explore such things. These are very important. It is not about just for a small processor or for small task. I told you, mobile phones are using ARM architecture. They are still processors. Intel tried to get into a mobile market, but it failed. So there is a this difference between the architectural issues. Okay, it is not just you can talk about one particular solution and compare with the other. You have to compare apple with apples and oranges with oranges. Cannot go and compare apple and oranges directly. Anyway, we have to move. Okay, so please explore these things. It is not just from my course perspective. You go and explore these things. Why ARM is not used in most of the computers? Still Intel is producing such solutions, or AMD is producing solutions. And what are the limitations of operating systems also? Why the computers are not using Android, or why Linux is not generally used in mobile phones? Why Windows mobile phone failed? Go and explore such trivial questions. These are the very important questions, I believe. It is not just about this course. Okay, you have to be more knowledgeable about the market also. There are so many questions to be answered, and when you search it, we can go. Otherwise, we can have a detailed discussion some other time, but I have to continue with the course. Okay, so how the load operation works? Load operation, we generally use this instruction from the instruction set LDR R1 comma R0. We know that the data from the R0 will go to the register R1. Okay, so remember, ARM microcontrollers or microcontrollers that we are going to study are based on 32-bit data, and they are 32-bit system. Okay, so this instruction LDR R1 comma R0 in the bracket means the instruction says the data from the address pointed by the contents of temporary register R0 will be loaded to R1. What does that mean? It will do something like this. So you have the memory here. Okay, this is your memory. All the addresses will be 32 bit. So remember, the address bus is 32 bit, and the data which ARM handles is also 32 bit. But the memory that we have designed, the registers, individual registers are of 8 bit. Please clear this thing very clearly. Okay, Number of address lines, 32. Total data size, size of data, okay, size of data, size of each data is 32-bit, okay. But the memory which is designed, okay, individual registers, okay, are 8-bit. So that means every time whenever you are going to move some data or add some data or load or store some data, you will be using 4 registers together, okay. So let us see here, what does that instruction LDR R1 comma R0 means? Load to register. So here we are starting from 2000, 2001, 2002, 2000. It is 32-bit. Remember, each bit is 4-bit. So it is, suppose if I'm saying 20000003, then remember this is 32-bit data or 32-bit. Okay, we are talking about 32-bit system. So this 3 is 0011. Then this 0 is 0000. Okay, this is 0000, so on, and then you have 0010. Okay, so in total this is 32-bit. Okay, so this is 32-bit address, but data here which is stored inside individual register is 8-bit. So 01 means 00000001. Please clear this thing very first of all, okay. Otherwise, when we continue to talk in future, you might get confused. So here the address is 32-bit address. Individual register that will store the data will be 32-bit. Individual data is also 32-bit, but individual registers which are designed in the memory are of 8-bit. So whenever we talk about a data will comprise from the data retrieved from 4 registers like this. So the total data is 01, 02, 03, 04. Okay. So when we say LDR, the data which is stored in the register R0, okay, is pointing to a memory location. Okay. From there, the data will be loaded to your register R1. R1 is also 32-bit register. So 32-bit data has been moved to register R1. So what is the data here? 04, 03, 02, 01. Okay. So this address is the lowest address which is pointing. So this is the MSB part, MSB, and this is LSB. Clear? Why? Because ARM Cortex M4 follows little endian system. I will talk about that also, don't worry. Okay, that why the data which is stored in R1 is not 01, 02, 03, 04. This is not the sequence which is loaded into R1. Rather, it is 04, 03, 02, 01 because it is following little endian system. Okay, so remember, data inside R0 is pointing to a memory address. From there, 32-bit data will be taken and loaded to R1 following little endian system. So MSB will be the highest memory, contains the highest first data. Okay, it will be going to the first sequence. This is the way load operation is performed. Anyone having any difficulty to understand?
Excuse me, sir.
Hmm.
Sir, can you repeat, sir? You have told us earlier also why it is मतलब starting में 0x क्यों use किया है?
0x is hexadecimal. It is representing hexadecimal. I will come to that also. Don't worry. 0x is representing hexadecimal data, right? So it represents every individual number or every individual digit is represented in an hexadecimal way, right? So 0x01. Okay, that means this is hexadecimal 0. So 0000, and this is 10001. For example, 0x, this one also. So each individual number is represented in hex. It is not just a decimal number. That is the representation of 0x. 0x means hexadecimal. We will come to this part in when we will be doing C programming also. So 0x represent hexadecimal. Okay, it is following Little Indian. I will come to that part also. But anyway, first of all, बोलिए.
सर मेमोरी जो डेटा साइज है वो 8 बिट है और टेम्परेरी रजिस्टर का 32 बिट साइज है डेटा.
Yeah.
स्टोर
These registers are 32-bit register. So 32-bit register means because this is 8-bit data, you will need
yes, sir.
4 registers, right? So 4 registers, so 4 into 8, that is 32, right? 32, and that 32-bit data will go to the. Now the only thing that you have to remember is the highest address data, the MSB, will be taken from the highest address, not from the lowest address. MSB will be from highest address. Okay, this is load operation. Similarly, when we look into the store operation, just opposite to that, store, the data instruction set says str r1 comma r0. Similarly, the same thing happens. R0 is nothing but a pointer which is pointing towards the memory, and the data in the R1 will be stored. That means the data is going from the microprocessor towards the memory. So store operation, right? So it is pointing to a memory. Okay. And the data present in the R1 will be loaded to that particular memory address. So this is what the sequence will be. Okay. So 01, 02, 03, 04. So the MSB is loaded in the last. This is the last to be loaded, and this is the first to be loaded. First. Okay. First. So the first will go to the lower address. The last bit will go to the higher address. Okay. So this is what the sequence of events actually is followed in ARM architecture. Okay. And then whatever mathematical operation you want to do, that mathematical operation will be conducted within these temporary registers also only. Okay. It will not be conducted directly in the memory. Remember, no ALU related operation will be conducted within the data of the memory directly. First, you will have to bring it to the temporary register. Then only you can do arithmetic or logical operations. Okay. Follow this. It is not that difficult. Okay. So MSB last. MSB will be coming last. Okay. LSB will be coming first. Store instruction. Again, Little Indian system is following. Now, coming to one more important feature, which is called aligned and unaligned data / memory allocation. What does that mean? Let us first look, just focus a bit here, okay? Because these are the basic fundamentals that will help you to understand what is happening in the ARM. We all know when we do or when we write a program in C, for some of the very important things are the data type that you choose. When we write a program in C, when we are writing a program in C, especially when we are writing from the computer science perspective, or when we are writing for a computer, we think that, okay, always use int. It is not that. You always should go for int. Because when we are writing a program for microcontroller, the memory is the most important or the most valuable thing. Okay. So here, for example, let us look into the data types briefly. Char, I believe most of you know what does that mean. Char means to represent a character. It takes only 1 byte or 8 bits. Right? I believe all of you know that. Short takes 2 byte or 16 bits. Okay. Int takes 4 byte or 32 bits. Remember, we are talking about a 32-bit system. Do you know what is the size of int in a 64-bit system? Size of int in 64-bit system.
8-bit.
No, int is always representing the size of the bit system of the microcontroller itself. So if you are using a 16-bit system, int will be representing 16. If you are using 32-bit system, int will be representing 32. If you are using a 64-bit system, int will represent 64 bits. Okay, this is confusing, right? This is confusing now because you never thought about int to be such a complicated variable or data type. We always thought int is always 4 byte, short is always 2 byte, char is always 1 byte. But no, it is not like that. Int is basically going to take the size of the system itself. So if it is a 32-bit system, int will be 32-bit. If it is 64-bit system, it will take 64-bit. Long and int, okay, for a 32-bit system are of same size. Both takes 4 byte. Now the theory changes from the computer science perspective. I'll prove it. Okay, don't worry. I will show you these things in the C program itself. Don't worry. Long takes 8 byte, or you can say 64 bits for a 32-bit system. Okay, float takes 4 byte, double takes 8 byte, and long double takes 16 bytes. So these are the size for the numbers which you want to represent in decimal format. Remember, these are the data types which you use to represent direct numbers like 356 or 4253, something like that, or 8964, something like that. But here these data types are generally used to represent some numbers like 223.256, right? To 325.68 or something like that, right? So data types float are used for decimal number systems. Okay, now this was becoming a very big headache for the programmers who were using microcontrollers, and of course for the computers also, because the computer was also evolving with respect to time. First it was 8-bit system, then 16-bit, then 32-bit, and then 64-bit. So which data type to be used for which kind of systems? Otherwise what will happen? The backward compatibility. Have you heard of this term?
Yes, sir.
Backward compatibility. That means when you design a system for, or you designed an application, you designed a game, and at that time you designed that game for a 32-bit system, or you designed a game which was for 64-bit system. Can that game be played in a 32-bit system or not? And that became a very big headache, because variables like int created a very big headache because it was defined for the size of the system itself. Now you cannot change the int again and again. So what happened? There, the community of the engineers sat together and they came up with solution, something like this. Have you seen this kind of data type? Int 8 underscore t, int 16 underscore t, int 32 underscore t. Have you seen this kind of data types? Have you seen or not?
No, sir.
No,
No, sir.
because using such data type reduce the headache of the programmer, because these declarations actually help to clarify that whether it is going to be used for any kind of operating system or any bit system, the variable size will be always the same. It will not be changing automatically, because this kind of system will remain always constant. 8-bit system, 16-bit, 32-bit, 64-bit. Here it is not about int only, it is more detailed int. Okay, I will come to this part also, when this thing was declared and who declared it. So remember that ARM mostly uses 32-bit microcontrollers. Now 64-bit are coming, but still mostly even now in this market, most of the microcontrollers are 32-bit system, and they uses 4-byte boundary. 4-byte means 4 registers each of 8-bit. Okay, and now for that they always go for these kind of memory addresses: 048C, 048C. What does that mean? Remember this number, okay? 048C. What does this mean? That always the memory is going to be in this particular addresses. Okay, 048C. Please make note of this thing. We will come to the clearance later. Okay, so first of all, the issue is with this thing, that int is not an independent system which is always going to be constant 4-byte. No, it changes with respect to the bit of the system. Secondly, therefore this kind of system was introduced where you declare the variable with a particular size, and then you can switch it to any particular operating system or any bit system. The size of the int will be always stable. You don't have to worry after that. So this is one solution. Second, ARM uses memory addresses or addresses which are always following 048C. It is, can you correlate why 048C?
So they address
So it takes 4
the
bytes at
memories
once.
of 8-bit and the
Yeah,
address of 4
right,
bytes.
right. So if you see here, we have the memory here. If you start filling from 0000, okay, so we have this 32-bit address, right? 32-bit address. So the first data which will go to this memory will be of 8-bit. So maybe for example 0x01. Then next address will be taken. Then next address will be taken. So 4 such addresses will make one data, 32-bit data. So that means 0, 1, 2, and 3 will make one data, right? So the next data will always start from 04. Then the next data will always start from 08. Then the next data will start from 0C. Clear? So the boundaries, these are the boundaries, okay? So we can say these are the boundaries. So always the boundaries are at 048C. Okay, there are so many interesting facts coming up. Okay, don't worry. So these are the boundaries which are always followed by 0, 4, 8, and C. If you represent it in hexadecimal, you will always find that 0 means 00. Last bits are 0. Last 2 bits. Okay, 4 ka last 2 bits are 1, 0, 0. Again 0. You see here, right? If I go to represent it like this, so the last 2 bits are 0, 0, 0, 0. If I am going to write 8, again last 2 bits are 0, 0. Clear? C means 10, 11, 12. 12 means 8, 4, 0, 0. Again last 2 bits are 0, 0. Last 2, right? You see here the similarity. So always the memory, last memory is at 0, 0. This is one important thing to remember. Clear? Any doubt in this part? Because you cannot, of course, digest all these things together, but try to understand. ARM uses 32-bit data. Memory is of 8-bit size. Okay, 8-bit. So you need 4 registers. You need such 4 registers, 4 8-bit registers, okay, to make one data, one 32-bit data. So always the data will, if you are starting from 0, next data will start from 4, next data will start from 8, next will start from C. And if you check the representation, the last 2 bits are always 0, 0. Please keep this thing in mind, okay?
Excuse me, sir. So how do we store a character? Because that is 1 byte and we store in
I
4
will come to that. I will come to that. I'm going to correlate this thing. I'm going to show what are the complexities which are going to arrive with this kind of systems. Wait, don't worry. Okay. Now the question is, remember, you always should start from 0, then 4, then 8, and then C. Now the question, just a simple question came. Now there are data types which are char, short, right, and int, and long, or long. It is your choice. Now this is 8-bit. Okay, this is 16-bit, and this is 32-bit. Now the question itself is there. That means if I'm always going to deal with 32-bit data, I don't have to worry about it. But what about a data which is character? It is going to take only one register, right? So char will take only one register. Or suppose if you are going to store a short, then you will be taking 0405, right? So these two memories will be reserved by short. Now what about the ARM architecture? Will it go from 5 to directly 8, or will it start from 06? This is the question which should come to your mind also. Okay, ARM always jump from 0 to 4 to 8 to C. But what about these kind of data types which are not of 32-bit? Then how the memory is managed? Will it go from 5 to 6, or will it grow from 5 to 8? Because you have both options. So remember this question, okay? I hope you understand the question. Anyone who is not getting this question, ARM always uses 32-bit data, which needs 4 register. So the registers boundaries are always at 0, 4, 8, C. But when we deal with data types which are character or short, which are not of 32-bit, in that case, what will happen? Will these 3 registers not used in case of char, or will these 2 registers from the 06 and 07 not used, or will it be used? Because otherwise you will be wasting memory. This is wastage. This is wastage, right? This is waste. You are wasting 2 byte. Again, here if you are using a char, you are going to waste 3 registers. So we are going to waste something. Clear this question or not? किसी को नहीं समझ में आया question? Okay. So now the problem is with the data types like char and short, which are not of 32-bit. Therefore, the question comes, or the topic comes, aligned and unaligned data. What does that mean? Aligned data and unaligned data. Okay. So here the solution is, remember, not all the ARM processor support unaligned access. Okay, remember, not all the ARM processors support unaligned access. That means M0, if you remember M0, M1, M3, M4, M0 do not support unaligned data access, but M4 do support. Okay, M4 supports. I will show you these things also in the programming. Okay. Those devices including TM4C, 123GH6PM, this is a microcontroller we are going to use. It supports unaligned access of memory also. What does that mean? Aligned and unaligned memory. Aligned means you always go from 0 to 4 to 8 and then C. Unaligned means you can go to another memory also. For example, there are these variables: unsigned char, unsigned short p, unsigned short int c, unsigned int d. So here you can see this is 8-bit, right? This is 16-bit, this is 16-bit, and this one is 32-bit. Okay, so A is 8-bit. So here you see the data starts from 2000 0000. So 8-bit data goes here, A. I'm talking about first unaligned system. That means you will use all the memory registers. You will not leave any address or any register wasted. Okay. In this, you will use all the registers. So 2000 A is entered. Then you declared the next variable short B, which is 16-bit. So 8-bit, 8-bit. So it is 16-bit. Clear? Then you declared int C, which is also 16-bit. So here is the 8-bit of C, and then here is the 8-bit of C. Okay. So in this way, if it is unaligned, you can see the data is scattered among all the registers. Okay, it is not following that so-called formula or the function that is go from 0 to 4 memory address, then from 4 to 8 memory address, and go to 8 to C memory address. No, it is not following that. Okay, so it is not allowing to waste a single byte also. All the registers are occupied. This is unaligned memory allocation.
So एक मेमोरी एड्रेस के वजह से 8 बिट डेटा होता तो 32 बिट डेटा कैसे आ रहा है इस पे मेमोरी एड्रेस को पॉइंट करते हुए?
Okay, sorry, here it should not be 1. I think it should be 4. Okay,
Right, so
4 and 8. Yeah, don't worry. Typo. Okay, let me just change this thing. Otherwise, yeah, it should be 4. Here it should be 8. Okay, yeah, no worries. Takes time to make presentation, and sometimes it happens when you're writing or making the present. Okay, so clear. Now the question is, this is unaligned, where you don't miss any register. Whereas in case of aligned memory system, char A, it is 8-bit. So 8-bit data is gone to the memory. Now you have 4 registers, right? Out of that, 1 is gone. Now if you are declaring a variable which is B, what it will do? It will take 16-bit. So it will take these 2 registers to fill the 16-bit. Now you see the alignment has been done. Next data is going to 4 here. So now you are declaring C, which is 16-bit. You see here 16-bit. And rest of the 2 are vacant, or we call it padding. Similarly, lastly, when you declare D, D takes all the 4 registers. Clear? So this, in this case, when you are saying aligned memory allocation, there will be wastage of memory. But remember, this kind of memory allocation is much faster than this kind of memory allocation. These are slower. Anyone? Why? This is slower and this is faster. Anyone?
So
Sir,
fetching
because
the data is easy.
Yeah, when
memory
you
is
are whenever you are fetching the data, or when you are going to write a data, you don't have to worry about the boundaries. Okay, so it becomes more complex algorithm to fetch the data from unaligned data memory addresses. Suppose you took 216-bit and then added, and it became 32-bit, and then you have to write it. Here you see it becomes difficult to go from here, because the microcontroller always points to the address which is 32-bit system based. It will always go to this address first, then it will look, okay, 3 hai kya, it will, shall I go for the 4th, or so on. So that kind of algorithm or that kind of memory allocation takes much more time than this kind of structured memory allocation, which is much faster also. I will show you some more disadvantages that whenever you are dealing with stack or something like that, in that case also, because it is not necessary you always store the 32-bit data in the stack, sometimes 8-bit or 16-bit data will go, and that will make more and more complex situations in such cases. So remember, there are this kind of address alignment system also, which is called aligned addresses and unaligned data addresses. Okay, so in aligned data, which is faster, but it is wasting memory, and we call that padding. Okay, you will come across this kind of terms in C programming also, padding of memory and all. What does that mean? It means using the allocation or allocating the memory according to the bit size of the system 048C. If suppose tomorrow you go for a 64-bit system, you will have to go for the addressing in this different way. Okay, so this is padding. Okay,
So,
Mhm.
so please explain the MSB and LSB part. How we have allocated this.
This is following Indian system. Okay, so I'm just saying that, for example, okay, what happened to A here? Okay, wait, so this small a. Okay, MSB, that means I will show you these things or discuss it these things when we will discussing Indian system, how the memory or the data is stored according to Indian system. Okay, I will come to that. Don't worry. How the memory or the data goes to which memory address for the Indian. Remember, this is all about Indian systems. Okay, when I'm saying this is MSB part, that means this is going to the MSB. For example, B also has got MSB and LSB, right? So the MSB, that means this will be the MSB part of the Z. For example, B is 0103. So MSB is 0103 is LSB. So 01 will be here, 03 will be here. Okay, clear? It will follow this sequence of allocation, because you see higher data will go to higher address. Understood? Hello?
Okay, sir. Okay, sir.
For example, this is 00, then 01, 02, 03 memory, right? Memory wise. So the higher data goes to higher memory. Okay.
Okay.
So that is why I am showing here the MSB part of the data will come, not the LSB part. It becomes sometimes difficult. For example, D, if you are writing something like AA, BB, CC, and DD, this is 32-bit data. Clear? So D is this one. This whole data is D, right? How that data will go to the memory? Here it will be the MSB, so AA, then BB, then CC, and then DD. Clear? This is how it is arranged. Higher MSB, sorry, MSB will be here. So AA, MSB, and DD here. Okay, DD, CC, and BB. Okay, so the higher address will go to the higher address only. Okay, now ARM Cortex architecture. ARM Cortex M4 follows 32-bit system, or it is a 32-bit microcontroller. I'm going to stop it here, okay? And just with this particular technique, okay, 3-stage pipeline. It supports 3-stage pipeline. It is a hardware architecture. I believe you remember hardware and Newman architecture. Hardware architecture means what? The data and the code will go to 2 different memory addresses. This is hardware, okay? Hardware architecture. So the data will go to one memory segment and the code will go to the other memory segment. Whereas in the Newman architecture, the code and data resides in the same memory. Okay, it is using 3-staged pipeline. It follows single precision floating point. I will show you that also, don't worry. And in single cycle of the clock, you can do multiplication. In one clock, you can do multiplication. And multiply and accumulate, that means in the multiplication itself, the result is stored in the accumulation also. That's why it is single cycle multiplication. In one clock itself, it can do the multiplication and the result is stored also in the accumulator in one clock itself. Does not take more than that. It uses thumb 2 instruction. Okay, I will tell you what is thumb 2. Thumb 2 means 32-bit microcontroller, but it supports both 16-bit instructions and 32-bit instructions. Okay, though it is a 32-bit system, okay, it supports both 32-bit instructions and both 32 and 16-bit instructions. So it supports both instruction set, 16-bit and 32-bit. So that those instructions which comes under thumb 2 includes 16-bit thumb instructions. So instructions are not always 32-bit. There are instructions which are 16-bit instructions also. So microcontroller M4 supports both instructions. So previously built instructions are also supported in M4. Okay. Okay, I believe I have finished the time. Okay, no worry. Leave it. We will end it here. In the next class, we will go to deeply dive into ARM architecture and all. By that time, please install the software, this particular code block,